Hello and welcome back to another VMK in the game development series. In this VMK, we're going to continue on building the scene graph mechanism that we'll be using inside of our game engine. We've already talked about the node class and the node transform. In this VMK, I'll be showing you how to implement the node shape class. And the way that the shape class is going to work is very similar to how VRealm contains the shapes. Inside here, you notice that we have a transform and we have a shape node. Inside the shape node, there's going to be geometry, a material, a texture, as well as a texture transform. All of these things are going to contain ourselves. And then depending on how we want to render things, we handle things appropriately. So let's take a look at this. Let's begin by creating a new CPP and .h file. So we'll select CPP. And inside here, let's just type node shape. And we'll repeat that for the .h as well. Okay, let's start off with the .h file. Inside here, we're going to include our node.h because our node shape is going to inherit from node. So we need node.h. And we're also going to include geometry.h, material.h, texture.h, and texture transform.h. We're going to comment out the material.h, texture.h, and texture transform.h because we're not going to implement these right away. We're going to implement these shortly after we get our scene graph working. We don't have geometry.h implemented yet, but I'm going to leave it uncommented just because we're going to run through the process of actually rendering things to the screen, and we want to see things. So to do that, we're going to need geometry.h. Now let's take a look at the node shape class. We inherit from node, so we have public nodes here, and we have a constructor, destructor, an update, and a render, just the same as we had for the node transform. Our public members are going to contain a pointer to a material, a pointer to a texture, and a pointer to a texture transform. And again, I commented all three of these out because initially we're just going to use some default values and we're going to assume that none of these are going to be equal to anything. Later on, when we go and add materials, add textures, and add texture transforms to our objects, then I'm going to uncomment these and actually show you how to get them working. Lastly, at the very bottom here, we have a protected member, and it's going to be a pointer to a geometry. So this shape node is really a shell. It's going to interact with the node transform as well as the nodes, which we created before. However, all the actual geometry that we want to render is not going to be stored inside this class. Instead, it's going to be stored inside geometry. And as a matter of fact, it's not going to really be inside geometry. It's going to be inside of a member that's inherited from geometry. So as you remember before, we had all of our different objects inside the object library. We had a house, a triangle, we had the flat grid. Well, now, everything that we're ever going to want to render to the screen has to inherit from geometry. So that's one of the differences between the scene graph and the old system. With the new system, everything will be coming from one kind of class, and it's going to always branch off from this class. And this is going to allow us to be a lot more modular, a lot easier to program to get different objects rendered on the screen. You'll see how this works in a bit. So that's the .h file. Let's save that. And let's go into the CPP now. Okay, at the top we include node shape.h, and here we have our constructor. So with our constructor, whenever you create a node shape node, you need to pass into it what kind of geometry is this shape going to be associated with. So when you do that, inside the constructor, you must pass in a pointer to a geometry. Now the thing is, the geometry you pass in could be anything. So for instance, let's say our triangle, our house, and our flat grid have been converted to the new system. Well, when you create a node shape, you can pass in a flat grid. And that's okay, because a flat grid class will be inherited from geometry. So it doesn't matter that flat grid is its own class, so long as it's all inherited from the same thing. So you could pass in a flat grid, you can pass in a house, you can pass in a triangle. for this node shape, it's not going to know the difference because it's all coming from an inherited system. That's the nice thing about using inheritance. Now, the same thing that we did inside the node transform, we need to also specify the type inside our node shape. And our type here is going to be shape, so we specify shape. And then we need to initialize our pointers. So our pointer to our geometry is going to be equal to the pointer that is passed into us, so we set those equal. And by default, we're going to set our material, our texture, and our texture transform equal to null. But because we've commented these out, we're just going to comment the initializations inside the constructor out as well, since these members really don't exist yet inside this class. Our destructor doesn't have any work to do. And then we have our render OpenGL. Now, we're going to be coming back to our render call here many times, because every time we add a new item, like a material or texture or a texture transform, we need to go and modify how this render OpenGL works. But by default, for now, we're always going to assume we're going to use a specific material, so in other words, a specific color for all of our objects, and we're not going to have texture, so we don't worry about those things for now. So inside of our code here, if we will have a material, we'll go and do some specific work. But for now, we're going to leave this blank. Otherwise, if it's null, or in our case, we will always go inside here, we then go do the following. We'll change all the colors of the object to be sort of like a solid gray, similar to what you see here inside VRealm. It's all the objects, no matter what you create, be it, let's say, a box or a cylinder or a sphere, whatever. Notice they're all about the same gray color. Well, that's what we're going to do as well. All of our materials are going to have the same value. Later on, if you want to go and say, no, I don't want to use this gray color, you can go assign a new material to it, to a specific object, and then go in here and specify a color, and then that object will change to be that color. So we're going to do the exact same thing. By default, we're going to make everything solid gray. And the way we implement that is we need to create a floating point number that has 4 parameters. Now, it has 4 parameters because we have red, green, and blue, that's 3, and the 4th parameter is the alpha value. And if you remember back to the section in the old system, when we're using colors, we always had 4 parameters. The alpha value controls transparencies, and the red, green, blue parameters control the actual color that the overall object will look. So we're doing a similar thing here. Instead of using GL color, as we were doing before, now we're using GL material. And with GL material, we have a bunch of other kinds of parameters we can tune to make objects look more realistic. So we have ambient color, we have diffuse color, specular, emission, and shininess. And I'm not going to talk about these in detail now. Instead, I'll save it whenever we go and implement the material class. But in general, what we're doing here is we're just setting a bunch of default values so that the object itself will kind of look shiny. You notice it has shading to it. It's darker on the sides and shiny in the middle. And it always looks kind of gray. So these values here give that impression. So our ambient, we set red, green, and blue to be 0.2. And we set the alpha value to be 1. So we pass that in. We then change the red, green, and blue values to 0.8, and we pass that into the diffuse. That gives it the gray color. And then we set the specular, emission, and shininess all to 0, so we do that here. Underneath that, we have another condition. If we have a texture for this object, we'll then go and do some work here, but because we don't have this member variable yet, we're not going to do anything. And then by default, we're always going to go inside this else statement. So inside this else, what we do is we call the geometry's render OpenGL function. Now, again, we haven't implemented the geometry class yet, so this render OpenGL is going to be kind of unknown to you. But realize this. This function for the node shape has render OpenGL, and we pass into it this render solid. I'll talk about what this render solid thing is going to do later on whenever we're finished implementing everything and we can actually run it. But for now, realize this render solid value that we pass in here should not get passed into render OpenGL for the geometry. It's not the same parameter. The parameter that gets passed into render OpenGL for the geometry is true or false, and if it's true, that means we want to render the geometry with textures. If it's false, we don't want to render the geometry with textures. And the distinguishing factor, the true or false here, is going to determine how to handle some code inside the render GL for the geometry. But again, we'll talk about that a little bit later whenever we implement the geometry class. Lastly, just the same as of our node transform class here, you'll remember that inside the render OpenGL we had, if we go in, we then do a bunch of stuff, and then we recursively call ourselves. And then if there's a next, then we go and recursively call ourselves. Well, we have to do the recursive call again inside node shape, or else everything will break down. We don't have a p-in value for a shape node, and I'll talk about that again later, but realize this: whenever we have transformation nodes, we're allowed to nest things underneath them. Whenever we have shape nodes, we are not allowed to nest things underneath them. So in other words, you can't have a shape node and then have a child underneath the shape node doing something else. That's not allowed. That breaks the foundation of how our scene graph works. So you'll notice here we don't do any sort of condition checks for MP-in, because MP-in is the pointer to the children of the specific node. That doesn't play a role here. Instead, we do have an MP-next. An MP-next we do have to handle, so recursively, if there is something beside us, or again, at the same parent level as what we are, as what this current node is at, we have to go and handle it. And the way we handle it is we just call that guy's MP-next render OpenGL. And here we do pass in the render solid Boolean value that was passed into us. So that's what happens inside render OpenGL. Lastly, we have our update, and again, I won't be talking about this until we go later on and implement stuff here. One thing I will have to do here now is I'm going to comment these lines of code out as so, and I'm going to comment this out here. If I don't do that, then I won't be able to compile this later on whenever we want to go and render this function. Same thing here, we need to comment out MP texture as well as this little bracket down here. So by default, we're always going to go in, set our color to be this gray color, and then we're going to go and render with no textures. When we finish implementing these other classes, the material and the textures, then we can then go back into here and uncomment these guys here and get everything written and working properly. So that's it for now, and come back for the next VMK, where I guess it's a matter of implementing the geometry class. Actually, I just took a look at the geometry class, and it's very simple. So because we do have time right now, I can go and implement it straight away inside this VMK. So to do that, let's go inside of our object lib. So we're no longer inside scene lib, we're now selecting object lib, and we're going to create the geometry.h file, geometry.h, as well as the geometry.cpp file. Okay, let's start with the geometry.h. Okay, at the top we have our if not defined, define geometry, and then we have our class called geometry. Our class will have a constructor and a destructor, an update, and a render OpenGL. Now, geometry is going to be set up to be a purely virtual function, as you can see here, virtual and then equal to 0. However, we're not going to be using it directly. We're always going to inherit something from it. So by default, there's nothing else inside this class. We're just leaving everything blank. And because of that, we can quickly go inside the geometry.cpp and implement it. Here we include geometry.h, and inside the constructor and our destructor, they're all left blank because everything that we're going to need to do is going to be specific to different kinds of geometries that we're going to implement. And since at this point, at the root of the geometry, we don't know what we're going to be working with, so everything's left blank. And that's it. So that's why I said I should implement it now rather than leave this for an extra VMK. Okay, let's close this off, and let's go and build the project, see if it actually builds. And it does. Okay, excellent. Now, in the next VMK, we'll go and convert the flat grid to use this new geometry. And then after we do that, we can then go and make the modifications to our scene so that we can render the flat grid on the screen. Once we do that, then we'll be able to actually start playing around with the scene graph, make sure everything's working properly, and start adding in details such as materials so we can color the objects, textures so we can have them textured again, and then we'll implement texture transforms. We'll also go back into our texture class and add some extra parameters into there so that we can do extra things that we couldn't do before. So some pretty exciting stuff coming up. Come back again, and if you have any comments or questions, feel free to go to the community website here and post any questions or comments, and yeah, let me know how I'm doing.